All right, ladies and gentlemen, welcome again to another video of the course. So in this video, we're going to talk about a very widespread and popular concept in computer sciences as well as in mathematics, which is basically recursion. So what is recursion? Recursion, to put it simply, is the fact that a function can call itself inside its definition. That's for computer scientists. That's how they define recursion. Recursion also could be considered as a way to solve problems that are defined by themselves, in terms of themselves. So if you have a problem that can be solved by solving its subproblems, then you can think of that as recursion. So you take a problem and you divide it into a bunch of smaller subproblems, and then you solve all of those subproblems, and then you combine them together to get the solution for the bigger problem. In that scenario, we use something called recursion. Here's a very simple example of recursion. So the simplest example we can think of is the factorials example. So for the factorials in mathematics, factorial is defined as, that's factorial, that's the exclamation mark stands for factorial. So 4 factorial equals 4 times 3 times 2 times 1. So n factorial is n times n minus 1 times n minus 2, and so on, so forth, down to 2 times 1. So whenever I tell you what is factorial of n, you keep multiplying n times n minus 1 times n minus 2, and so on, down to times 3 times 2 times 1. So all of those products are what is the factorial of n. Okay? But we can also define 4 factorials to be 4 times 3 factorials, right? Because this quantity here, 3 times 2 times 1, is also 3 factorials. So, and again, the 3 factorials, all of this 3 factorials could be defined by 3 times, that's 3 times this quantity here, which is 2 factorials, and so on. So basically, we can think of any number, n factorials, will always equals to n times the factorial of n minus 1. So n minus 1 factorial. Okay, so n factorial equals n times n minus 1 factorial. And this is a recurrence relationship because the factorial operator is defined in terms of itself. Okay? So let's write this in a different way. Let's say that there is a function called fact which takes a number n and it multiplies n times n minus 1 times n minus 2 and so on up to 1. If we use this recurrence relation, then we can say that the factorial of n equals n times the factorial of n minus 1. Okay? So this is a recursive relation. Okay? If we want to write a simple algorithmic function recursively, say for this factorial, for example, it'll be something like this. So we have a function called fact that takes an integer n, and this function is defined as follows. So if n equals 0, then in that case, the function factorial equals 1. Because by definition, the factorial of 0 equals 1. Otherwise, if n is different to 0, then you can define the factorial of n, the factorial of n equals n times the factorial of n minus 1. And that's a recursive function. So if we translate this function into a programming language that supports recursion, like C or C++, for example, then it'll be identical to this. Okay, so we would have here an int, a fact n, that's an int n, and if n equals 0, then fact return 1, otherwise return n times fact of n minus 1. Okay, so let's write a program here. Let's write the C equivalent. So int fact, let's add in the type there. So that's int n, and this function is returned like is defined like this. So if n equals 0, then return 1. Otherwise, return n times the factorial. You can see here the function is using itself. It's calling itself, okay? The factorial of n minus 1. So let's say we want to compute factorial of 4. So here's what's going to happen. Factorial of 4. Does 4 equal 0? No, 4 is different to 0. Then we're going to execute the else statement here. So we're going to return n times factorial of n minus 1. So the factorial of 4 actually equals 4, which is n times factorial of n minus 1. Factorial of 4 minus 1, that's factorial of 3. So factorial of 3. But factorial of 3, it needs to be computed, right? So 3 is different to 0, so factorial of 3 is also equals to 3 times factorial of 2. So the function is calling itself. Factorial of 4 is calling factorial of 3, which is in turn calling factorial of 2. And the same thing here, so factorial of 2 equals 2 times factorial of 1, which is the same thing, equals 1 times factorial of 0. Now factorial of 0 here, 0 equals 0, so there will be no function call anymore. Factorial is not going to keep calling itself forever. It has to stop somewhere, and this is the somewhere. It'll stop where when n equals 0. So by definition, factorial of 0 here, we said return 1. Factorial of 0 equals 1. So 1 times 1, so we get here 1 times 2, so factorial of 2 equals 2. So 2 times 3 to get the factorial of 3, so that's 6, and 6 times 4 to get the factorial of 4, which is 24. Okay, so that's a basic example of recursion. So let's test this with code blocks. So I'm going to write this example function here. So fact, it takes n, and we said if n equals 0, then we return 1. Otherwise, we return n times fact of n minus 1. And let's test this function. So I'm going to printf an integer, which is the fact of 4, and this should print 24. And the answer is correct, that's 24.